We all think we kind of get the rules, right? Gravity pulls stuff down. You can't walk through a wall. Simple. But what if the real rules of our universe are way, way stranger than we think? What if reality itself just plays by a different set of rules when you get super tiny or unimaginably huge? Well, that's exactly where we find modern physics.
So, in our everyday lives, we're dealing with what's called classical physics. And honestly, it's great. It perfectly explains everything from a falling apple to a planet going around the sun. But here's the kicker. The moment you shrink down to the world of a single atom or zoom all the way out to the scale of an entire galaxy, those dependable, common sense rules, they just completely break down.
Okay, so what does happen when the laws of physics that we see every day just stop working? What kind of new, bizarre rules take over in these extreme places?
And that question right there brings us to this huge split in physics, the jump from the classical world to the modern one.
Yeah, modern physics isn't just a little update. No. It's a total game changer, a whole new way of looking at everything. It's the science we absolutely need to explain how nature really works, in those places where our gut feelings just don't apply. We're talking the super small, quantum level, and the mind-bendingly vast cosmic scale. And this new way of seeing the universe, it doesn't just bend the old rules, it throws them right out the window. This whole new framework is built on two absolutely revolutionary ideas, two pillars that change science forever. All right, first up, let's dive headfirst into the weird, wonderful, and totally bizarre world of the super, super small. Let's talk about the quantum world. So the science that governs this tiny little place is called quantum mechanics. Think of it as the official rulebook for all the fundamental particles that make up, well, everything. We're talking about the electrons buzzing in your atoms, the photons of light hitting your eyes right now, all of it. And folks, this is where reality starts to feel like science fiction. In the quantum world, a particle, like an electron, doesn't just have one specific location. Nope. Instead, it kind of exists as a cloud of possibilities. It acts like a particle and a wave at the exact same time. All we can ever know is the probability of finding it in any one spot. It means that deep down, at its very core, the universe is built on uncertainty. How wild is that? Okay, so we've gone from the incredibly small. Now let's give it to the incredibly large and incredibly fast. And that brings us to the second massive pillar of modern physics, Einstein's relativity. So Einstein's theory is actually a 2-for-1 deal. First, you have special relativity, which tells us something mind-blowing, that space and time aren't fixed, they're relative. The faster you move through space, the slower time literally passes for you. And that wild idea led him to an even bigger one, general relativity. This one completely rewrites our understanding of gravity. Turns out it's not a force at all. Instead, it's what happens when huge amounts of mass and energy literally bend and curve the very fabric of space-time itself. Think about it. A massive object like our sun creates this huge dip in that fabric. So planets, like Earth, aren't being pulled by the sun. They're just following the curve, like a marble rolling around in a curved sheet. Gravity is just geometry. So, just to recap, we've got this strange world of quantum fuzziness on one hand and the cosmic scale warping of space-time on the other. Now, I know these ideas can sound pretty out there and abstract, but believe me, they are absolutely crucial for the technology you and I use every single day. Yeah, this isn't just some theory stuck in a textbook for physicists to argue about. Quantum mechanics and relativity, they're the hidden engine that makes our modern world go. I mean, think about it. Every time you use a laser pointer or boot up your computer, you're tapping into the power of quantum mechanics. Those tiny semiconductor chips inside your phone, they only exist because we understand the quantum world. And get this, your GPS wouldn't work for more than a few minutes without relativity. The satellites have to constantly correct for the fact that time is literally ticking faster for them up in orbit than it is for us down here on Earth. It's incredible. So, when you look past all the amazing technology, modern physics is really about something much, much deeper. It's about our species' unending quest to figure out the fundamental rules of reality. It's about peeling back layer after layer to try and see how the universe really works at the deepest, most fundamental level possible. If you enjoyed diving into the strange and wonderful rules of the universe and you want more explorations into science like this, make sure to subscribe to our channel, 4 Corners of Science. Thanks for watching.